Hello everyone. In this video we are going to discuss about the page replacement techniques. There are various page replacement techniques that are available in virtual memory concept. So before going to discussing about the various page replacement technique, we should know about why we need the page replacement. So already we know about what is demand paging. So if you want to execute any of the page that are available in main memory, so that will be taken as usual by the CPU for execution. Suppose if the required page that is not available in main memory, then what we have to do, we have to transfer that page from secondary memory to main memory. Then only CPU can able to fetch that particular page from the main memory. If the required page is not available in main memory, then that is nothing but demand paging. So we have to get it back from the secondary memory. While we are keeping that new page into this primary memory, if suppose there is no enough space, there is no free space that is available in main memory to hold that incoming page. So what happens, we have to do any of the old page that is already available in main memory should be chosen for replacement. So that is what we are doing here. So we have to select any of the page that is already available and that should be taken for replacement. So that should be replaced and the new page, whatever it is required by the CPU, will be placed into the main memory. So this is what page replacement. Let us see how it works logically. So initially we have to refer the page table. So page table is the information that holds the particular frame number of the searching page. So here it will we can able to get the frame number. Correspondingly, we can able to include one more bit, that is valid or invalid bit. So each and every page that is available in main memory, so which is whether it is available or not, so that information we can get it using this valid or invalid bit. If the frame is valid means then this particular page is available. If suppose it is invalid means then particular page is not available, so that we can get that information from the page table. So first step is we need to refer this page table, and after referring it we can able to know about whether the availability of that page. Suppose if the page is not available, then we can go for swap out operation. So swap out operation means any of the page should be selected for replacement. So that is what we are doing here. Any of the frame should be selected as a victim and that frame should be swap out from the main memory and it should be placed in the secondary memory. So this is the first step. And after doing this, second step is page table should be changed, because in some of the page that is already available, which is set as a valid, now we have taken out from the main memory, so we need to change that valid bit to invalid bit. So that is what second step. Third step is swap in operation, which means currently whichever the page that is required by the CPU, that particular page we have to take from secondary memory and we have to place it in the primary memory. So after doing the swap in operation, again we need to reset the page table accordingly, because initially that particular page is not available in main memory, so that its corresponding bit is invalid. Now we have placed that page into the primary memory, so that its corresponding bit should be changed to valid bit. So again we have to reset the page table entry according to the new page that is available in main memory. That is the fourth step. So this is what the steps to be followed whenever you are performing this page replacement technique. Now, so we have several page replacement algorithms that are available, and also we have some frame allocation algorithms. So whenever you are allocating any of the new frames, so we should select any of the free space or free frames that are available from the buffer. The buffer is nothing but it's a place where maintaining the list of the free frames, and from that we have to get any of the free frame, and that should be given for storing the new page from the secondary memory. And the next one, so while we are going to study about the page replacement algorithm, we should know about what is reference string. So reference string is nothing but string of memory references. So although we have many number of bits that could be used for specifying each and every location in the memory, but it is too hard to represent each and every bit. So if it has 16 bit or if it is 8-bit location, so it is too hard to represent a 8-bit address or a 16-bit bit address for referring each and every frame. So we have just for simplification, so we have only one bit that we are using, or a kind of a number, decimal number, that we are using to represent each and every address of the frame. So let us see each and every algorithm. So first one is FIFO page replacement. So first one is FIFO page replacement algorithm. As the name suggests, it is nothing but first in, first out. So whichever the pages that is entered initially, that is in which order they have entered into the main memory, in the same order we have to choose that particular page to be replaced. So for replacement, how we are selecting the pages? So that is what this page replacement algorithm. So here we have some set of reference string that are available. So consider all these reference string which are nothing but the page number, just for simplicity, so that we can easily understand the concept of this page replacement algorithm. If you look at this is actually the frames, list of frames that are available. Say for example, if you have 3 number of frames that are available and all these 3 frames are initially empty. So we need to allocate the first 3 set of pages into these frames. So the first frame, which is nothing but first page, which is nothing but 7. So 7 has been allocated. So whenever the page, the searching page or referring page is not available in main memory, then that is nothing but page fault. So whenever you are implementing any of the page replacement algorithm, so we need to consider how many number of page faults we are actually getting. So if you follow this FIFO page replacement, so we need to consider how many page faults we are actually getting. So here initially that page 7 is not available, so it is one page fault. Okay, and next, so 7 has been allocated into the free frame. And the next one, 0 page has been referred, which is not available, so it is a second page fault. And next one, 1 has been referred, it is also not available, so it is a third page fault. So far we got 3 number of page faults. Now we are actually referring page number 2. So we need to check whether this page 2 is already available. No, it is not available. If it is not available, then we have to choose any of the page that is already available for replacement. So how we are choosing the page for replacement? So whichever the page entered first, so that page should be selected for replacement. So here, as per the list, the first page that has entered, which is nothing but 7, so 7 should be chosen for replacement. Okay, so we are selecting first 7 to replace with this 2. So now page 2 is available. This is again one of the page faults. So far we got only 4 page faults. And again, what is the next page reference, that is 0. We need to check whether 0 is available. So yes, it is already available, so no need of replacing any of the new page. And next page is 3. 3 is already available or not? So no, in this list we don't have page number 3, so we need to replace that page 3 with any of the page that is already available. So in the given list, 0 is the page that is entered first, so we have to select this page 0 for replacement. So page 3 will be replaced with this page 0, so that is one of the page fault. And the next one is, next reference string is 0. So 0 is not available, so we are choosing this page 1 to be replaced with this page 0. So this is another page fault. And again 4 is available or not, we are checking. So 4 is not available, so we are selecting this 2 because 2 has entered first among these 3. So 2 has entered first, so 2 will be selected for replacement, and that will be replaced with this 4. So like that, whatever the reference string you are getting, you have to check it with all the reference string, and we have to check how many number of page faults we are getting. Okay, so far, so we are actually getting 15 number of page faults as per this page replacement algorithm, that is FIFO page replacement algorithm. If you follow this method, so we are actually getting 15 number of page faults. And what is this Belaudis anomaly? So Belaudis anomaly, which is nothing but, if you are having the graph like, so how many number of frames we have allotted? Only 3 number of frames. And if you are increasing the number of frames, at one case, if you are increasing the number of frames, again the page faults also be increased. So but in common, so if you're increasing the page frames, and your page faults should be decreased, but if it is increased means then which is nothing but Ballard's anomaly. It should not happen at all, right? At some case, but if you follow this FIFO page replacement, so you will be getting this kind of problem. So we are just telling it as a Ballard's anomaly. So we need to avoid this kind of situation. So we are going to optimal page replacement. This is the next algorithm, page replacement algorithm. So if you look at this, again we are getting the same reference string, but how we are actually selecting the page for replacement, which means we are not following the FIFO type of replacement. So here we are just following. In future, whether we're going to get that same page again, we are checking the history of, not history, so we are just checking the future reference string. So if you look at the first reference, that is the page number is 7, which is not available in these 3 frames, so we are just allocating, so it is 1 page fault. And 0 is not available, so we are just allocating. 1 is not available, so we are just allocating. So we are getting 3 page faults. Now the next page number is 2. We are checking whether it is available. So we are not checking in the free frame list. So it is not available. So it is a page fault. So we need to select any of the page to be replaced. But how we are selecting this one? So we are just selecting this 7 because in future we are checking in the list of reference string. So which page we are getting initially, right? So after this 2 we are getting 0. So we should not select the 0 for replacement. After this we are getting 3, and after again we are getting 0, and after that whether we are getting 1 or not, we are just checking. So we are getting 1 in this place, and after that only we are getting 7. So among these 7, 0 and 1, we are getting 7 at the last, that is after referring this 0 and 1 only we are getting 7. So in future after referring this page 0 and 1 only we are getting 7. So this is the best page to replace with the new page. So 7 page will be replaced with the 2, and afterwards we are getting 0, so no need of page fault, and again we are getting 3, so 3 should be replaced. So which one? So among these 2, 0, 1, which one we are getting at the very far in the list of the reference strings, that you have to check. So 2 we are getting and 0 also we are getting. So 1 we are getting after referring this 2 and 0. So 1 should be replaced with this 3. Okay, and after that you are getting 0. So 0 is available, so no need of going for the replacement. And 4 we are checking whether it is not available. So 4 should be replaced with which page? So among these 2, 0 and 3, so which one is referred? Which one will be referred at, whether it is present at very far or not. So you have to check in the list of reference string that we going to refer in the future. So here among this 2, 0, 3, after this 4, so 2 you are getting next reference itself, so you should not select this page for replacement. And 3 you are getting, and 0 also, so you have to replace the 0 because 2 and 3 afterwards only you are getting 0, so you have to replace the 0 with 4. So like this we have to check how many number of page faults you are getting if you follow this kind of scheme, that is optimal page replacement. So now you are getting number of page faults which is nothing but only 9. So it is very minimal number of page faults we are getting if you follow this optimal comparing the previous one, that is FIFO replacement. Whereas in least recently used, it is somewhat better than the FIFO, but it is not better than optimal because we are checking the history of the reference string. So whichever the string that is referred previously, that we are checking in this least recently used. So how many number of page faults we are getting if you follow the least recently used? So after allocating all these three pages, we are checking for 2. 2 is not available, but 7 is 7 among the 701. 7 is least recently used, so we are just choosing this 7 for replacement. So like that, if you follow how many number of page faults you are getting, only 12. So number of page faults for this least recently used is 12. So it is somewhat better than FIFO replacement, but the efficient or the yes, efficient page replacement algorithm among these three, which is nothing but optimal. So it will reduce it has the very minimal page faults. So we can say it is efficient than the other two page replacement algorithm. Thank you.